So good morning, everyone. I welcome you back to my YouTube channel. I'm presenting before you this wonderful tutorial is Hampeyo Climate. We have another interesting question from cell physics on vectors, and the question goes like the helicopter view in figure, which is picture 1.70, shows two people pulling on a stubborn mount. Then we're told to find the single force that is equivalent to the two forces shown, and then B, the force a third person would have to exert on the mount to make the net force equal to 0. Okay, the forces are measured in newtons. Okay, so we can get solving the first question. Okay, so we can just write our data. Okay, let me just try to get my pen. So, all right. So, we can write everything here. So, the first thing to do in order for us to solve this question is simply to write a diagram. So my diagram is going to be like this. Okay, and then I'm going to have a line in this direction, which I can call my x, and then I'm going to have this line which I can call my y, and then I've been told that I have a force which is being exerted to in this direction. Okay, and I'm calling that force my F1. Okay, then we have been told that it is equivalent to 120 newtons at an angle theta of 60 degrees. And then I also have another force. Okay, this is a person pulling a force in this direction, and then I've been told that this force is force 2, and it is equivalent to 80 newtons, and then this force is 75 newtons. Sorry, it is 80 newtons at an angle degree of 75. Okay, so now after writing this, we can compute F1 into components. So I've been teaching about components for some time now. So to compute F1 into components, it will be like this. Okay, we have a line moving due upward, meeting this particular force. So we have our F1x, and then we also have our F2x. So if we come here, we compute everything into components. We are going to have our F1a, our F1x. So my F1x is going to equal to F1 cosine the angle theta. So this is going to be F1x is going to equal to, what is F1? F1 is 120 cosine my angle is 60 degrees. Let me see what I'm going to get. So this is just 120 cosine 60 degrees. Okay, so this is 120 cosine 60. Okay, so we are getting 60. Okay, so we're getting 60.0 newtons and then okay, 60.0 newtons, like that. And then we can calculate for F1 Y. F1Y F1Y is going to be F1, which is 120 newtons, sine 60. So if I put sine of 60 there, I do my calculation, I say 120 sine 60, that is going to be sorry, let me just do my calculations. Let me do my calculation. Okay, so 120 sine 60, we are getting 103.1. So this is going to be 103.9, like that, newtons. Then we've done the F1s. Now let's try to get to do F2. So for F2, okay, for F2 we also have a vector which is moving due upward, like that, and this vector is holding up to the resultant, which is F2. So to calculate F2, we are going to say that F2x is this vector moving in this direction. So F2x is going to be negative because our vector is in the negative direction. Okay, so this is going to be 80 newtons cosine 75, and we need to get a negative answer. Sorry, even if we get a positive answer, but our answer should be negative. Okay, so this is going to be negative 20.7 newtons. Okay, we get F2y, which is going to be 80 sine 75. So this is going to be positive because our y is positive, like that. So let me try to punch that 80 sine 75. What are we going to get? We are getting 77.2, like that, newtons. So now, after getting everything, we will need to add all the x. So I'm going to add this to that. Okay, so summation of all the x, okay, summation of all the x, and I guess I'm supposed to use f. Okay, it's okay with our resultant. So this is going to be 60 plus negative 20.7, and I'm going to get 39.3 newtons in the x. Okay, then to get my RY, I'm going to add everything in the y, and that is going to be 103.9 plus 77.2. I'm going to get 181.1 newtons. Okay, so this is supposed to be newtons, not degrees. let me just grab everything. Okay, so that was supposed to be newtons, not degrees. Okay, and this was supposed to be fx, and then this is supposed to be fy. Okay, so this is supposed to be newtons, and that in newtons. So upon getting all the forces, we can now find the resultant. Okay, to calculate the resultant, we are going to say that F is going to equal to fx power 2 plus fy power 2. So this is going to be F resultant equal to the square root of what do we have? Okay, so this is 39.3 plus what do we have? We have 181.1. We have 181.1 newtons. Okay, so if we punch everything, we say 39.3 power 2 plus 181.1 power 2, then we find the root of everything. We are getting the answer of 185.3 newtons as our final answer. Okay, which makes sense. To find the angle or direction, we are going to say that theta is going to equal to tan inverse of fy over fx. Theta is equal to tan inverse of what is fy? Fy is 181.1 over f2 is 39.3. So theta is going to equal to, so tan inverse of 181.1 divided by 39.3 is going to give us 77.7 degrees as an angle. Now the question was asking, we find a force a third person would have to exert on the mount to make the net force equal to 0. So what force are we supposed to exert on this guy in order to make it 0? Remember when I was teaching addition of forces of vectors, on the part where I was teaching negative of a vector, I said the negative of a vector A is simply a vector A such that when you add it to this vector, it should give you 0. And if you add this vector A 1 to this vector, which I can name x, if you add this vector 1 to vector x and it gives you 0, it means that vector x was negative. Okay, so a negative vector is a vector which when you add to it, it must give you 0. Okay, so in that case, one of them was negative. So in order for us to get a resultant of 0, we'll need to get a force which is going to be equivalent to our final resultant force, but on the opposite direction. So in this case, the force that would be needed in order to make this particular force equivalent to 0 is negative 185.3 newtons. This makes sense because we know that accordingly to Newton's laws of motion, if you have a force pulling in this direction and another force pulling in this direction, then you find the summation of these forces, you find a resultant force upward. Then this resultant force which you are using to pull this mount is also experiencing a force downward, which we are calling as the resistant force or opposing force. And this force is in opposite direction to the force that is being applied, but the two forces are equal. Okay, so that is Newton's third law of motion. For every action, there is a reaction that is equal in magnitude but opposite in direction. And that is exactly what we did here. So we have this particular force of this magnitude. It should be equal to the opposing force, but the directions must be opposite. Henceforth, this one is negative, the other one is positive. If you understood and enjoyed this video, consider subscribing and also hitting the like button. Thank you so much.